Tom Cowan is a man that needs no introduction, unless that is you've been sleeping under a rock, or maybe you're a new listener to the Way Forward podcast. And in that case, Dr. Cowan is a well-known alternative medicine doctor, author, and speaker, renowned for his common sense, holistic approach to health. With a background in general medicine and a deep understanding of natural principles, Dr. Cowan continues to share his wisdom through lectures, workshops, and publications. He's author of several books, including The Contagion Myth and Cancer and the New Biology of Water. As the vice president of the Weston A. Price Foundation, Dr. Cowan remains committed to promoting holistic health practices and empowering individuals to take control of their own well-being. And he's also a gracious sponsor of the Way Forward podcast through his New Biology Clinic. It's a terrain-based online health clinic that offers individual consults, classes, lectures, education, trainings of various types. And they actually offer practitioner training as well to train in the new biology approach. It's really incredible. And if you haven't checked it out yet, I highly recommend doing so. Here soon, I'll be teaching some of their movement classes through teaching Qigong on the platform, which I'm really excited about. And Dr. Cowan is such a breath of fresh air in his approach as a doctor. At the very least, he has you laughing quite a bit, but that's not just it. It's the way that he thinks is so incredibly logical and basic, but I mean basic in a good way. He helps bring you, through using creative analogies, back to the foundations of questioning some of, quote, modern science, quote, accepted paradigms, let's say. And the paradigm that we're discussing today is the DNA dogma. We're discussing the foundational so-called evidence for DNA in the double-helix model. And that may seem counterintuitive to question something like that, because you may consider that to be a, quote, well-established paradigm. Well, a few years ago, Dr. Cowan thought so too. Just as I thought that virology was a well-established paradigm a couple years ago, I am now questioning the foundational principles and foundational so-called evidence for DNA. And that's not to say that you can't trace back your lineage, or that I'm not clearly different than a dog or than an ant or than a flower. That's not what we're saying at all. Those are, again, the effects. Those are the things that we see, the observed natural phenomena, so to speak. What we're questioning is the foundations that supposedly lead to the differentiation between those things, and claims surrounding DNA and DNA coding for proteins and things like this. That's the whole point of this episode, is just to question the foundation, because if we're coming from a flawed paradigm to begin with, that then has downstream effects that lead to people thinking that, quote, bad genes lead to disease, bad genes lead to obesity, bad genes lead to cancer. And that also leads people to, be concerned with some of these pharmaceutical products that are being introduced and them, quote, permanently altering your genome. Well, have we even discovered the human genome? I don't know. You'll find out during this episode. So thanks for tuning in. And the last announcement before we get started is our Confluence tickets are going on sale soon. I don't know if by the time this episode releases, those will be up, but if not, just save the date at the least. Confluence this year will be May 7th through the 12th, 2025. Really stoked for our third annual edition of this event. Again, if you want to experience like-minded community with a bunch of organic food, incredible workshops, lectures, music, dancing, magic shows, breathwork, Kundalini yoga, movement classes, and magnesium-rich pond. There's so many things that I could say. This event is truly incredible. If you want to experience what it's like to be amongst a strong, coherent field with like-minded community, then definitely come check out Confluence this year, May 7th through the 12th, 2025. Hope to see you there. All right, Tom, thank you for joining me. I have gotten over the slip up of saying Dr. Cowan, and then you do this whole thing where you correct me and say it's just Tom, and you don't call your plumber Joe. That's, you have some of the best analogies. One of my favorite things about watching your Wednesday webinars is when you have the technical difficulties. Like the other day, you were kind of worried that your microphone went out, and then someone called you on that phone that you have sitting next to you, and you talked on who calls you? Is it Linda?
I know, Trisha.
Oh, Trisha. Okay. Got it. Okay. Well, for this discussion, I was really just impressed with your assessment of DNA and the lack of evidence for it, which may come as a surprise to some of those who are listening and watching. But it's ironically very similar to virology, and it relates directly to virology, but also relates to us as human beings. And um, I guess let's just start with your understanding of the so-called discovery of the double helix model of DNA through Rosalind Franklin and then sort of expanded upon by Watson and Crick.
Yeah, I mean, it actually, the story I think really is better started even earlier than that, because they were already working under the proven assumption, they thought, that there is something called DNA. And by the way, that it's in the nucleus, and that it is essentially the blueprint or the code of life. But that's a vague statement. So what they meant by that was that there's something in the DNA, a chemical found in the nucleus of all living things, that is a determining factor in the so-called phenotype, which would be what we would refer to as the way an organism looks and behaves and acts and all that. That's the phenotype. The genotype is the DNA. Okay. And, as you said before we started, like I don't consider myself an expert on this. I'm piecing together what I'm finding, basically, but I can't say that it's like everything else. I'm stealing people's work, basically. And then occasionally, well, then I go to the original sources and see what I can find. So what I found is that, so the question, where do they get this idea that there is something in the nucleus, a chemical that is the determining substance of our phenotype, in other words, who we are? And that started with a guy named Michener in late 1800s.
1869.
Yeah, a lot of these things started. So you know about this story.
Yep.
Yeah. So basically he, took pus and got the white blood cells and extracted the nuclei, which I think you can do. And then he did a bunch of chemical extraction with it and came out with a chemical that was rich in phosphorus. And he said, well, that's interesting because all the other previous substances, i.e., proteins, are rich in sulfur, not phosphorus. And so I found a new substance. And this substance came from the nucleus, and it must have something to do with, the sort of code of life. Because they already had this sort of evolutionary theory at that time, meaning there was a physical code of life in the organism, which I would say was an unproven theory at the even then. But so the questions of that, the first of all, the interesting reason why he may have gotten a phosphorus-rich chemical was that all the previous extractions were done with sulfuric acid, and he used phosphoric acid. So if I had been there, I would have said, like, yo, Michener, are you sure it's not because you used phosphoric acid that you got a phosphorus-rich chemical? Because he obviously didn't do controls. But it also begs the question, which I've asked a lot of analytical chemists, none of who can seem to answer this. If you take living substance from anything and then you mix it with something like a very strong acid, and then you get a chemical, how do you know that mixing it with the acid or whatever else you're doing, freezing it or drying it or whatever, didn't make that chemical appear or didn't change what was in there in the living system? Because in order to say that, you would have had to have done a control, meaning extract it without doing the acid. But the retort of that is, well, you can't get it without doing the acid. So they're right. There is no control possible.
Right.
In which case, an honest person would say, I don't really know if this thing was there in the original tissue, because there's no way, technically speaking, that I can find that out.
And doesn't that mean that it's unfalsifiable then at its foundation, which means it is by definition unscientific at its foundation?
Yes, it's a belief.
Right.
You simply believe that these chemicals are in living substance the way that they appear once you've extracted them with methods which are uncontrollable.
Mm-hmm.
Which means you can never falsify it, which means that's the definition of a belief.
Right.
So we don't know that that chemical was there, and we certainly don't know whether the method of extraction produced this chemical. And it's in fact likely that it did. And, as this woman, Tam, who wrote this really brilliant piece on DNA, I'm sure you've read that.
Yeah, and I'll link it into the show notes for those who are watching and listening. It's an incredible article.
Yeah, it's incredible. I probably read it 10 times, try to get it straight. And I've talked to her, is why would anybody, first of all, think that the inert part of a living tissue that you look at under a simple microscope, which is the nuclei, that the code is somehow in there? Not the sort of active moving part, which we would call the cytoplasm. So that's a question. And why do we think there's a chemical that's the code in the first place? Well, the answer to that is because we think that living beings are basically a chemistry set, right, which is also not exactly a proven theory, right? That's like weird. So there's a whole lot of questions in that. But then anyway, so they have this chemical. And then there was a paper, they attempted to prove that this chemical determined the phenotype. And this was with pneumococcal bacteria. So a type of pneumococcus, which either has a capsule or not a capsule. So it could come in two different forms. And they exposed the types without the capsule to this different chemical, and then it ended up having a capsule. So they extracted a chemical, that what they call DNA, from the nucleus of a pneumococcal with a capsule, right? And then they put it in a culture of pneumococcus that don't have capsules, and they were able to transform the uncapsulated pneumococcal into capsulated pneumococcal, which they said proved that DNA was the driver of the bacteria making the capsule. Now, on the face of it, that seems pretty impressive and convincing. In other words, they changed the phenotype. They got you to grow an arm by putting the arm DNA in there. And if you didn't have the arm DNA, you wouldn't grow an arm. And this gets into a lot of the things with virology and just science in general and medicine. They don't tell you that they also change the conditions in the culture. Like why is that relevant? They would say. Like we hear that all the time. Like we hear it with the control experiments, so-called, with virology. Well, we change the amount of antibiotics in
Right.
the control versus the experiment. But that doesn't matter because the only reason for the antibiotics is to kill the bacteria.
Right.
Well, that's weird, right? Because like they also have proven that antibiotics, kill the culture.
Right.
So you can't do that, at least unless that's the independent variable that you're trying to study. But if it's not, which it isn't, then you can't do it. And if you did do it, you'd have to report it. But they
Can I
don't.
expand upon that real quick, Tom, just to like
Yeah.
drive that point home? What he's referring to is that in the so-called mock infected culture, first off, they don't typically, or in most viral isolation papers I've seen, and pretty much all of them, they don't actually explain what goes on in a mock infected culture. But when you press the authors of said papers to see what actually happened with a mock infected culture, they used a lower concentration of antibiotics and antimycotics because they already presuppose, oh, well, because we're not adding a human sample, which contains
Right.
bacteria and fungi, that means we don't need to add as much antibiotics and antimycotics in the so-called mock infected culture. Also, assuming that this antibiotic and antimycotic has no negative effects on the culture itself. It's just there and intended to keep the culture sterile and free of bacterial and fungal growth, which means they're not actually conducting a proper negative control because they're not following the exact same procedure, minus, again, the presupposed independent variable inside the human sample.
Right. Exactly. And they don't seem to get that just because you have an idea that it doesn't affect it, that doesn't matter. It because you like you say everything has to be identical except the thing you're trying to study. So in this case, they're trying to study whether this chemical, which by the way was never purified, right? It's with a whole lot of other things. So and it was never proven to originate from the bacteria intact. It's just a chemical precipitate with a whole lot of steps, and they put that in, and then they create the conditions that that give rise to encapsulated pneumococcus, and then they get encapsulated pneumococcus.
So what you mean by that, what you're getting at here, is that by changing the environment
Yeah.
itself, it gives rise to those conditions expressing.
Right. Now that gets into, again, with all this stuff, you have to be aware and understand the assumptions. So they assume that, all living things are unique, specific, unchangeable entities, phenotypes. In other words, frogs don't become mice, and we don't become, dahlias, and butterflies or caterpillars don't become butterflies, except actually they do. So it's a little, and tadpoles don't become frogs, except actually they do. But zebras don't become fruit flies. So there is no change. Species have one form, although it changes through the life, and they're specific, even though that's actually falsified by the caterpillar and the butterfly. And it's been seen over and over again with bacteria and fungi that they have different forms depending on the environment that they're in. This has been documented for at least 150 years, called pleomorphism. And then they made a decree around 1900 that pleomorphism cannot be mentioned in medical journals. So from then on, a pneumococcus without the capsule, that's it, the way it is, right? And pneumococcus with a capsule, that's the species. It never changes. And as long as you keep it in the same conditions, that's true. But what they had two variables going. They put it in the conditions, which they don't even tell you, really. You have to go digging for the experimental conditions. They changed them compared to the control, which was keeping the pneumococcus in the same, the unencapsulated one in the same conditions as always. They change the conditions. They add unpurified so-called chemical DNA, and it becomes encapsulated. And they say, see, we proved that it's the gene that causes the change in the phenotype, that becoming capsule. And that's just not true, because they didn't account for the fact, A, they didn't purify the DNA, right? So they don't know what else is in there that might be doing it. And B, change the conditions and actually recreated the conditions that gives you encapsulated bacteria.
Mm.
So that's weird. Like,
right.
Why would you do that? Anyways, that's a hard question to answer why you do it, except because you're looking for something and you're just determined to find it. So that became the paper that showed that it's the genes that control the phenotype. In other words, the DNA, sorry, they didn't say genes yet. The DNA controls how that living organism looks and its actual structure. Okay, so now they say they have the chemical and they say they have the function. And then they want to see, well, what does this stuff look like? And that's where we get to Watson and Crick. This picture it actually apparently wasn't really taken by a woman named Rosalind Franklin. But anyway, she got credit for it. So they take this picture, they take this chemical, which they get from the chemical extraction with centrifuging and dehydrating and, a whole lot of messing with it. And then they expose it to X-rays, I think 62 consecutive hours. Mm-hmm. And then they get an image on a screen or a piece of paper or something. And that you can see on the right, the hydrated form of sodium DNA. Now, again, that is not a purified DNA molecule. That is a unpurified chemical, which was extracted from a nuclei using uncontrolled chemical and physical techniques like centrifugation. And then they get this picture. And they said, wow, it's a double helix. And that became then the basis, the sort of physical proof for the Watson and Crick paper, which I do have here. It was in Nature, April 25th, 1953, The Molecular Structure of Nucleic Acids. So this is the first time in history that the actual structure of this chemical was proposed to the world in a scientific paper. Now, I've asked many people, doctors, et cetera, do you think there's DNA? Yes. Do you think it's a double helix? Yes. Who came up with the evidence, the proof that it's a double helix? I'd say 50% of the people know that. Watson and Crick. Okay, have you read the paper? So far, nobody.
Right.
And I say this and I'm critical and sarcastic and all that, but 5 years ago, I never read the paper, right? I went through medical school and pre-med and practiced medicine and talked about DNA, sort of, not really, but, I believed in it and I never read the paper. So I was just as guilty and illiterate as everybody else that I'm asking. So I say this not, well, look at how great I am kind of thing, but somehow we were convinced that this is okay. That's another weird part. Like, how come they didn't tell us, here's the start, like we're doing, here's how this came about, here's the paper, read the paper and see what you think. Nobody did that. Because when you read the paper, the first thing that's striking is there's not a measurement in the whole paper. So they're saying this chemical is the shape of a double helix. You've all seen pictures of that. And you would think in order to ascertain that it's that, we would have had to measure something.
Right.
But if you actually just read from the paper, so we assumed an angle of 36 degrees between adjacent residues in the same chain so that the structure repeats after 10 residues on each chain, that is after 34 angstroms. Then if it is assumed that the bases only occur in the structure in the most plausible tautomeric forms, it is found that only specific pairs of bases can bound together. Then I'll finish this and explain this. The previously published X-ray data, he's talking about the Franklin, are insufficient for a rigorous test of our structure. So far as we can tell, it is roughly compatible with the experimental data, but it must be regarded as unproven until it has been checked against more exact results. So let's go through the first one. They say if you assume a certain rotational angle, then you come out with a double helix. That's like saying, if you assume you have this structure that has 4 90-degree angles, right? Like this. Oh my God, I found a square. Well, yeah, because that's how you define a square.
Right.
I mean, if you assume that the thing is shaped like, like a sphere, I don't know how you would put that, then of course you find a circle.
In nearly all cases with modern health systems, you're waiting months for appointments only to spend a mere 10 minutes with a doctor who quickly hands out a generic diagnosis that is likely rooted in a total misunderstanding of health and causes, and then you're offered a one-size-fits-all medication or invasive treatments with unpleasant side effects. If this sounds all too familiar, consider a different approach with the New Biology Clinic, founded by Dr. Tom Cowan, a respected natural health doctor, author, and speaker. Dr. Cowan's holistic perspective on health and wellness and a deep understanding of the true nature of health and disease sets this clinic apart. With the New Biology Clinic, it's not about quick fixes and suppressing symptoms. The practitioners take time to understand your unique story, recognizing that health is unique to the individual and that illnesses have a variety of causes, physically and metaphysically. Members of the New Biology Clinic enjoy a flat monthly fee that includes a range of valuable services like health consults as needed, practitioner-led live streams on diverse health topics, access to a members-only resource library, and multiple live group sessions every month. These sessions cover fitness, breathing integration, biofield tuning, guided meditation, EFT tapping, and much more. Unlike traditional healthcare systems that thrive on frequent visits, prescriptions, treatments, and suppressing symptoms, the New Biology Clinic's motivation is to make you healthy and keep you that way. Visit newbiologyclinic.com to learn more and use code THEWAYFORWARD for $50 off your account activation. If you're a member of The Way Forward, email hello@thewayforward.com to receive $150 off your account activation. Your journey to genuine healing begins here. And correct me if I'm wrong, what they're referring back to ultimately is they're basing it off of this right here, these X-ray crystallography images.
Well, yeah, yes, that's
That's
only
my point.
physical.
Is like that's their only quote physical
That's
evidence.
their only physical evidence,
right?
And his wife was a drug addict, and she had a hallucination and saw snakes and double helixes. So that's the other part. So
Okay.
that's the two lines of evidence.
Got it.
Now, so that's crazy. And then the idea that the A matches with T and G with C, that's the second assumption. They assumed that that was the case. And so that it would work the best if they assumed that that was the case. Well, right. But in fact, their data of and other people's show that they're not a 50-50. Like they should be 1-to-1, 1A equals 1T. They're close, but they're not 1-to-1. So in fact, their actual measurements didn't fit that conclusion.
Mm.
And they have reasons. They say, well, there was mistakes or something. So in fact, there's no evidence in here of any kind of double helix at all. Zero. Now, I don't have the next paper, but turns out a bunch of undergraduate students, I think at a place called Suffolk University in the 80s or somewhere around there, actually ran the procedure that Rosalind Franklin used to get this X-ray picture. But instead of a chemical from the nucleus, unpurified, they used the spring from a ballpoint pen. And they got the exact same picture. Now, I think that's an important finding because I think it's a reasonable hypothesis that the code of life is actually the springs of ballpoint pens, which is why that there was nothing living before around 1930, right? Because that's when they invented ballpoint pens. And so since the springs are the code of life, then it's obvious that there was no living beings before 1930.
Right.
That's the problem with this stuff is, well, Tom, that's ridiculous. Of course.
That's the point.
But so is the other one.
Right.
That doesn't prove, all it proves is that if you put certain forms and X-ray the crap out of them, that you get images on pictures on screens. It has no relation. They tell us that DNA is exquisitely radiosensitive. So if you expose it to X-ray for 62 hours, on what proof do you claim that its structure is intact?
Right. And that's after centrifugation and other things like that, dehydration,
chemicals.
Well. Yeah. Right.
This is the opposite of science or rational thinking. So that then at that point, then you're left with, well, I don't think there's any proof that there is DNA in the first place, or that it's in the nucleus, that it's the code of anything, or has even any relevance at all. Then the next thing, and I don't think I've spoken about this because I didn't find this. I went looking then. So the next step. So now they now supposedly have the double helix code, and then you can propose a mechanism of replication. Then you get the zipper down the middle, and the code separates. And so the A's on this side are going to always match up with the T's on this side. And so now you have a sort of interesting, plausible, but made up mechanism for how one cell becomes two, and even how, like the sexual union, because there's these special cells that only have one part, and then they go looking for the other part. And so you end up with a theory of mitosis and meiosis. And so the whole thing's looking pretty good. Except it's all based on just models that have no relation to reality. And so then I spent actually a few hours this week looking. It's interesting. You asked the question to Google or whatever. I don't know how to do Chat GPT, but so how do we know that these sequences on the DNA called genes, right? So supposedly the way it works is you got this DNA and it's divided into segments, right? Long piece of DNA divided into segments. And the particular segments have start and stop codes, and they're called genes. And they code for proteins. And the way they do that is they make mRNA in the nucleus. It goes out of the nucleus and goes to the imaginary ribosomes in the cytoplasm, and then it gets translated into proteins.
Mm-hmm.
So I already know there's problems with that because A, I know there's no such thing as a ribosome. B, I know there's no hole in the nucleus. So there's no way that the mRNA can get out. And C, they also tell us that there's one gene codes for one protein. And there's approximately 100 to 200,000 proteins, and there's only 10 to 20,000 genes, which either means that geneticists are not good at arithmetic, or the whole thing is a bunch of hooey, or both. Because I don't know if they're good at arithmetic or not, but they didn't seem to catch that one,
right?
Which is a fatal flaw in the theory. And so then they say, well, but there's somebody rearranging them to get what they want. Like who? I mean, what's rearranging them? Anyways, whenever you make a theory that's falsified, then you have to keep the story going by making more stuff.
That's what we call rescue devices, right?
Yeah, right. They have to rescue the thing. So anyway, so I said, okay, let me find out who proved and how did they prove that that genes code for proteins, right? There's got to be an original paper. And it turns out, and this is where it's always good when you find this, everybody referenced the same paper. This is where it started. Here's the paper, General Nature of the Genetic Code for Proteins. Interestingly, by Crick. I don't know what happened to Watson, but
he had bad genes, so he must have got a disease.
Yeah, he had a problem. So this is Crick. So you're reading through the paper, and then you get to the section. So to be clear, this is the paper that is referenced for proving that genes code for proteins. Explanation and outline. Our explanation of all these facts is based on the theory set out at the beginning of the article, although we have no direct evidence that the B cistron, that's what they called the gene, produces a polypeptide chain, that's the protein, probably through an RNA intermediate. In what follows, we shall assume this is so. What the fuck?
Right.
This is the paper that's supposed, and they say that we assume that this is how it works. And then they go on to describe the whole thing of how it works and the triplet code and the amino acids, and there's no attempt or evidence or anything to just actually prove that this is actually the case.
Mm-hmm.
And then you end up with whenever that happens, you always end up with some observations that are weird.
Mm-hmm.
That's always the case, because you're starting with a model, and the model is an assumption, and then you gather some data, some evidence, and it's always weird. 100%. It's always weird. So here they have this thing. So each amino acid is a triplet code, right? ATG. And there's 20 amino acids, they say, proven. But if you go a triplet code and there's 4 different bases, that's 4 to the third, right? So that's 64 different combinations you can have. So how come there aren't 64 different amino acids?
Mm-hmm.
Because there's only 20.
Right.
So that's a problem.
Huge problem.
Huge problem. So you know what the answer is?
What's the answer?
The DNA code is what they call degenerate, which I think means that they smokes a lot of dope or drinks a lot of beer or something.
He has a bad record.
Right. DNA is degenerate, they say. But what it means here, let's say a certain amino acid like alanine is ATG. It turns out that the G doesn't mean anything. So it could be ATA, and that's still alanine. Or it could be ATT, and then that's still alanine. So it's not actually a triplet code because then the math doesn't work. And they're already they're better at math by this point. So then they have some amino acids are degenerate and some aren't. And you think, well, I mean, but that's all just to make the math work, right? Because they can't really prove that. And why would it be the same? They tell you that if it's a different base pair, it creates a different structure and a different charge, so it should be different, but it's not. These ones are okay, those ones not. You get a long amino acid, you can't change the code. You get a short one, then it's degenerate, and you can. And after the end of the day, it works out to be 20. Okay, fair enough. So then you get this code, and it codes for all the proteins, and that's where we got that from. Once it becomes like proven like this, then it's just a matter of sort of making the model work.
Right.
So that was the next step. So at this point, I don't see any evidence that the other thing that's interesting, and you get this a lot in quote science, they tell you things that just make no sense and that contradict. So the complexity of the organism is dependent on the genes, right? The DNA, that because that determines the number and the complexity of the proteins, right? Again, the complexity of the organism is determined by the complexity of the DNA, reflected by the number of genes and the complexity of the genes. Mm-hmm. So then they supposedly do the Human Genome Project, and they also sequence pufferfish and fruit flies, and we have a few more genes than fruit flies, but not as many as pufferfish. Which, given I think the complexity of most scientists, that may be true. We're somewhere between fruit flies and pufferfish. I don't mean to denigrate fruit flies or pufferfish, but that seems to be where we are, which is weird. Like, because then they go on about how we're the crown of evolution and all that stuff.
Right.
You'd think we'd have at least more than your average pufferfish. Now, again, I don't want to make disparaging remarks about pufferfish, but that doesn't make any sense to me.
No. You brought up this CDC article about the human genome. Could you touch on that a little bit? You brought it up in your Wednesday webinar, and I'll link the full webinar in the show notes because it's worth watching. It's hilarious.
Well, the final step was, if you ask including myself, again, I don't want to, okay, a few years ago, or in 2018. They sequenced the whole human genome. You see, this has a lot to do with the virology stuff, because it's common for us to say, well, the problem with sequencing a virus is you're not starting with a virus, right? You've got to have pure, isolated, only this one kind of virus. Then you can get the DNA and then you can sequence it.
Right.
Right? That's obvious. It's like with a tomato or a human being. They did the Human Genome Project. They started with a person. They took their DNA out and they sequenced it end to end, and they got the sequence. And you know that every bit of that sequence came from that person,
Right,
or that tomato, or that fruit fly, or that pufferfish. And that's what we all seem to think happened. But then I was given or read this article from the Atlantic, or it's maybe New York Times, or one of those ones. I know it's true, right? It's the New York Times.
right.
So it's about the human genome. The first draft was released in 2001 before a consortium. They had completed the job with the finished sequence in 2003.
This is the first draft of the human genome, right?
Human genome, assembled from chunks of various people's DNA. This became the reference sequence against which all other human DNA can be compared. So that was weird, because I thought they took Joe Blow and got his DNA. So it turns out they took a whole bunch of people's. And so I didn't know that.
Mm-hmm.
But then it's certainly the best that could be done at the time, but it has major gaps and errors. Later releases improved upon it, but many of the problems persisted. Over the last few years, technology has advanced where it's possible to read the entire genome without gaps and minimal errors. But these have all been composites using DNA drawn from multiple individuals. And this year, 2024, we're going to do it from one guy, Leon Peshkin. So let's just say, okay, this is talking about until 2023, every human genome was from multiple people, chopped up into little bits, assembled on in a computer. And there were multiple errors and omissions. In fact, they estimate 10% of the genome was missing. Now, let's think about that for a minute. If you've never taken a person and got their chemical and sequenced it from end to end, if all you've ever done is chop up little pieces of a whole lot of people's, and then you assemble it in a computer, just like they do with viruses, and then you have a composite genome, how can you possibly know if there's errors?
Right.
What are you comparing it to?
Shilajit is one of the world's most popular superfoods. It's loaded with over 40 trace minerals, fulvic and humid acids, antioxidants, and more. It's a resin or tar-like substance that seeps out of the rocks of the Himalayas at extremely high altitudes, formed from centuries worth of decomposing plant matter and microbial activity, distilled by pure rainwater and pressurized by tons of mountainous rock. In a way, you could say it's kind of like the lifeblood of the earth itself, and we can use it to enhance our daily lives by absorbing its power into our body cells. However, if you've tried Shilajit in the past, you know it's true when I say it does not taste good, and that almost seems like an understatement. Some people say it's like licking an old used ashtray, and some people get a little more descriptive than that. Let your imagination run wild. It's pretty bad. But one thing is for certain. I've tried tons of Shilajit products, and no one has ever been able to cover the flavor, let alone make it taste good, until now. My friends at Organifi just released these new Shilajit gummies, and they actually taste good. They deliver 250 milligrams per serving of pure Himalayan Shilajit. Shilajit's benefits include supporting energy production, healthy hormone levels, performance and recovery, promoting collagen synthesis and heart health, increasing cellular energy, and decreasing fatigue. Shilajit has become super trendy in the superfoods and holistic health world for obvious reasons, and people have long been desperate for a solution to the flavor problem. That's why, in the few months since Organifi released these, they've already sold out several times. Visit Organifi.com/TWF. That's ORGANIFI.com/TWF, or just head to the show notes. Take a look at their whole collection, and when you go to check out, use promo code TWF. That code is going to give you a 20% discount on all of their products, and they have a lot of amazing products other than their Shilajit gummies. Find out how these superfoods can help you on your health journey today with Organifi. And this is where you bring in the book analogy, which is so incredible. Unless you start with the book, you can't take little bits of paper, sentences, and then make the book. You have to have the book first to know what the book is like, know what the book is about, in order to restructure the book.
Well, right. If you take a book called like War and Peace, like 600 pages and the words are in a particular order. If I gave somebody a computer or somebody 100 million words or sentences and said, structure them into War and Peace, but they've never seen War and Peace. Nobody has ever seen it. As with virology, they're going to give you a million different options because there's no way for it to know which is the right option. And if you've never seen War and Peace, which they're saying they never had seen the intact genome, you can't know which one of those is correct because you don't know what correct is. And therefore, you can't have an error rate. And therefore, you can't know how much is missing. So how did they get there's 10% missing? And by the way, if there's 10% missing, and then they say, well, we took a sample from a person and we found the virus, and we did that because we knew which is the human, so we got rid of that. But then they say, but there's 10% which we've never seen. So how do you know that this part you're calling the virus isn't part of that 10%? Because you just told me 5 minutes ago you've never seen that 10%. So maybe that's the part you're calling virus, and you didn't throw it out because you didn't know it was part of the human. It falsifies the whole thing.
Right.
There is no human genome. There was no way to know whether they just did PCR on these chemical extracts and got a whole bunch of things and told the computer to align it and make all the different possibilities, like a million of them, and then they picked one. That's nonsense. And that's the Human Genome Project. Trillions of dollars to do that bit of nonsense.
And then all the things that are stacked upon it, all the implications for the world, our belief systems and medicine and CRISPR gene editing and quote mRNA vaccines, all of it. But correct me if I'm wrong on this. So what we're essentially getting at here is, given that they willingly admit that there is a lot of errors in the assembled human genome, right? Because it was assembled. Given that, and given that they say 8 to 10% of it was missing, that's what they say, right? However they determine that, right? So given that, and given that they've never actually demonstrated that there are these unique so-called obligate intracellular parasites called viruses with their own unique genetic material, it's again assumed that they have their own unique genetic material coming from a muck of a bunch of, quote, genetic material. It is possible, or at least they didn't check or consider this, that so-called, quote, viral genomes are simply the other pieces within the error rate of the, quote, human genome, meaning that other 8 to 10%.
That's one possibility. Another is they're just completely made up because none of this actually represents real stuff.
Right.
So that, but yes, even if you take it on their terms, just using their information, which they really give us, there would be no way to know that these viral sequences didn't come from the unknown 10%.
Right. And
Now
that's
they
all
have a
assuming that what they
story that
discovered is correct in the first place. That's all assuming that what they're looking at with these so-called genes and quote nucleic acids are actually representative of what happens inside an organism.
yes, that they have no idea. Yeah, I mean, it's a complete house of cards. And so, right, everything that comes from that, you know, criminal stuff and paternity stuff and crimes, yeah, and CRISPR and genetic modification of stuff. That's not what's happening. They don't have this chemical. They don't know how to manipulate it. I mean, when I've told this story many times. When I was in college and I ended up taking, you've probably heard this story, but I took this course in advanced cellular biology from a guy who was nominated for the Nobel Prize for discovering how DNA folds up into chromosomes. You probably know this story.
Mm-hmm.
And he was, a brilliant guy and like the head of Duke biology. And he was a great teacher. So he sets up this thread with stanchions around the classroom. And he said, if you did it to scale, the chromosomes, which supposedly are wound up DNA, are like the size of a thimble. So he had a thimble. And he starts winding the thread. He said it would go around the room like 20 times. Starts winding the thread in the thimble. It gets about halfway around one turn of the class. Can't stick anymore. He's got a stick, sticking it in. And he says, it's amazing that life can stick all this thread into this thimble. And we don't know how this works, but I've been working on it, and it's these certain bonds and all this. And I remember thinking to myself, wait a minute, because everybody was like, oh, it's amazing. And I said, he just showed us that you can't wind that stuff into that space. It doesn't work.
Mm-hmm.
And so I think there are chromosomes, as far as I can tell. I may have to eat my words on that. But the fact that they contain DNA, I don't buy it.
Yeah,
doesn't make any sense.
It seems to be, if there's anything, and this is pure 100% speculation, and I recognize that, something to do with the environment leading to how we as beings express, even down on that level, if you can even determine what happens at that level, which makes a lot of sense, especially from the terrain-based health perspective. Our biology is dictated in large part by our environment.
Yeah. Well, and to really speculate, because it does seem like, and I don't know, so many of these things, you have somebody with like Down syndrome or something, and they seem to always have abnormal chromosomes. Mm-hmm. What I don't know is that actually true? Mm-hmm. Do they actually, and then do you never find, quote, normal people who have that same constellation of chromosomes?
Right.
But let's say that's the case. That's not true. It is true that they have. So how do you explain that? If you think, like you said, the information is not, the analogy I use, if you go to a house, it's amazing structure, like Taj Mahal. I say, I'm going to figure out how they built this Taj Mahal. So I'm going to take one of the bricks and I'm going to dissect it and figure out where the blueprint for the Taj Mahal. And I first of all, it looks like just dust, like limestone. So it's not there. So it's in the calcium, and it's not there. And so it's got to be in the atoms, in the neutrinos. And so you keep going because you're committed to it's got to be in the bricks. And so you dissect it further and further until there's nothing left except mental gymnastics, and you don't find the blueprint. It's because the blueprint is not in the bricks. The blueprint is in the mind of the architect.
Right.
And so with living things, the blueprint is in the mind of creation,
Mm-hmm.
which you could say is the electromagnetic field.
I was just about to go there actually, because one of the things I wanted to discuss is the possibility of some interplay between electromagnetism and assuming that our cells are, if we even have cells, assuming our bodies are lined with fourth phase water, some sort of interplay between electromagnetism and water, irrespective of whether it's fourth phase water or just water in general, just some interplay between electromagnetism and what makes up us as beings.
Right. So there's got to be a antenna sort of receiver device, and it might be just the water, but it might be a kind of a structure like a chromosome, which may be a coil.
Mm-hmm.
So like the top of the Taj Mahal has a coil.
Mm-hmm.
And so it collects the ether, the electromagnetic field, and downloads that into the water. And you see that in literally thousands of structures from before.
Right.
Whatever before was.
whenever that was, exactly.
Yeah. So before. Because and so if you say, well, you got this chromosome sticking out of the dome, which is the nucleus, and it's harvesting the information from the field, and then downloading that, if you want to use that word, into our water, just like Taj Mahal downloads that electromagnetic field into the pool, or look at the National Mall. Right. Same thing. You got the harvesting the phallus, thing,
right?
And then the columns and the whole bit. And that's how to bring information into life.
Mm-hmm.
And so I think that's what it's doing. Then they made up the DNA story to basically distract from the reality, which is that this is an electromagnetic system, which has to do with then how the purity of your water, and maybe the integrity of your chromosomes. Like, so if you got weird chromosomes that are all broken, you don't download the field properly, and then you're sort of weird or off. And that's what we call disease. It has nothing to do with DNA, and it's not the code of the proteins. It's got nothing even to do with heredity, except as a downloader of the field. So I think that's at least an idea of how it might work.
And this is where people will say, well, you're falsifying DNA, or you're saying that it's all nonsense, but then how can you possibly claim this? Like, this is where I want to be clear, just to remind people, and I think Tom would agree with this, that falsification does not require replacement. I don't have to know what is to know what clearly isn't. We're just throwing out possible ideas. Of course, we know that these ideas need to be explored further, but it's like the analogy of, hey, Tom, you're guilty for this murder in Wisconsin. Well, no, I have evidence that's clear here that I was actually in Florida with Linda. Here's pictures. I had my son Asher there. He was there. We were texting each other. Here's receipts. Okay, well, it's clearly not you. But until you can find someone who did this murder, it's you. Well, no. I just showed you it wasn't me. Well, you can't explain it, so it must be you. That's what's happening when people say, well, until you can explain a better way that all this stuff works, whether it's virology, whether it's cosmology, whether it's genetics, then the accepted model must be the correct one. And that's not how it works. We're saying
not how it works.
Yeah, we're saying that we don't know for sure, but we have some ideas of how it might work. But clearly it's not this. And then the other question that comes up is people will bring up heredity. Well, how can I trace back my lineage? How does that work? How I seem to have the same quote code as they do. But then you brought up on the Wednesday webinar the example of your friend who submitted his stuff and but said it was coming from a dog or something like that.
Yeah, he submitted a sample from from him, and but he filled out the form as if it was a dog, and they said he was 30% Schnauzer and 40% Beagle or something. Right. So there's a lot of errors in that.
So unfortunately, Tom cut out, but what he was going to say is that the same can sort of apply to forensics and crime investigation. And I'm not going to make a claim on the accuracy or inaccuracy, but there is some interesting things to consider when the only way it appears that they can determine, or assuming that this part is even accurate as well, that something is human genetics is if they already have the presupposition that it's human genetics. Meaning that, for example, when his friend submitted his own genetic material to 23andMe, but claimed that it was a dog's genetic material, they then came back and said, oh, you are this percentage of this type of dog, this percentage of this type of dog, this percentage of this type of dog, which means they already have to have the presupposition, which shows that just by submitting, random genetic material, you would think that if it is as sophisticated as they claim that it is, when this material is submitted, they would say, no, 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 this isn't dog genetic material. This is very clearly human genetic material. But because he just checked the box that, yes, this is dog genetic material, I'm trying to figure out what type of dog this is. They then, quote, found that this guy who is clearly a human being has dog DNA. So it brings up a lot of questions related to so-called CRISPR gene editing technology, which I know everyone is very scared about. And that's not to say they can't do some sketchy things in these labs. And that's not to say that you can't trace back something that is passed from parents to their kids and so on and so on and so on. I look like my dad. I look partially like my mom. I mean, we all see evidence of that in our daily lives. Again, we're not questioning the effects. We're questioning the intended, or the supposed rather, cause of these phenomena. It's no different than virology. And just as Tom said, it's no different in virology at its very foundation. The starting point for the reference human genome is really no different than the starting point for so-called viral genomes, right? It's this muck of material with loads and loads and loads of added chemicals and assumptions. And so when you look back, that all this is ultimately based on a series of compounding assumptions, starting with this X-ray crystallography image. And I highly recommend you check out the show notes for this episode, especially because reading these papers of how DNA was claimed to have been discovered in the double-helix model specifically, and then reading Watson and Crick's paper, and then reading the other papers that Tom referenced, it really just raises a lot of questions. And to reemphasize again, you don't have to know what is to know what clearly isn't. And what all of this is indicating is that the current accepted model of genetics isn't at all. And then that has major implications, because ultimately it leads to things like the idea that, quote, bad genes causes disease, bad genes causes obesity, bad genes cause cancer, and so on and so on and so on. And that idea is embedded as a belief system into, the collective human psyche. And I think, this is my belief, that there is a strong, strong, strong indication that our own foundational beliefs have a direct impact on reality itself and on the outcomes of things. So, of course, this raises a lot of questions surrounding the idea that mRNA vaccines permanently alter your genome. And I know a lot of people in this, so-called anti-vaccine space, whether they want to admit it or not, they want to believe in that idea because it reinforces to them the idea that these things are bad. But what I'm saying is, just because the shots may not permanently alter your genome, that doesn't mean that they're not bad. Of course they're bad. Of course there's no reason to receive them, because at the foundation, there's actually no proof of the alleged cause necessitating these products in the first place. But of course, I am in full agreement that they're poisonous. I'm just saying that I don't think that there's any evidence that they, quote, permanently alter your DNA, or some of these other narratives that are being thrown around out there, because the very foundational aspects of this DNA model are questionable at their core. The foundations of genetics are questionable at their core. So because of that, everything established upon them are also questionable, if not totally nonsensical. So that's the whole point of what Tom and I are getting at here. And I think we need to be questioning all of these foundational things. And I highly encourage you to check out the video that Tom had on his Wednesday webinar in the show notes. I'll link that. And also, please check out New Biology Clinic. They are freaking awesome. And I'm going to be teaching Qigong for them here soon, which I'm really excited about. We're really honored to have them as a continual sponsor of the Way Forward podcast and really supporting what we're doing. And I want to say thanks to Tom for joining me. Sorry that he had to cut out early. His internet cut out. And thanks for tuning in.